Yeah. Too many things to process. Can you guys hear me well?
Yeah.
Okay. My name is Arvind Jade. I'm an architect leader at Nielsen. Along with Govind, my colleague, we're going to talk about our journey using Couchbase and our journey partnering with Couchbase on the Nickel and 4.0. So what are we going to cover today? I just want to go with the agenda so that everyone knows what's coming. We're just going to go a little over what Nielsen is. We're going to talk about answers on demand is where the platform me and Govind work in. What were our business challenges that made us choose NoSQL solution in general and Couchbase in particular? Govind, who's much, much smarter than me, is going to go into the technical details of all the usage models in Couchbase. He's going to do a demo on Nickel, right?
Yes.
Really good Nickel demo coming up, so hold on to your guns. And then we'll open up for Q&A. Nielsen, I'm not going to screw this up. I'm just going to read this verbatim. We're a leading global information and measurement company that enables companies to understand consumer and consumer behavior. So we measure what people watch and buy. Sounds a little bit like the NSA, but we're a lot milder than that. We have a huge presence everywhere globally. We're in about 100 countries and growing, pretty much in all the continents except Antarctica. I think we're getting there. So our ecosystem, if you look traditionally in the measurement channels, right, it was traditionally just TV, print, and radio. So over the last 10 years, there's been a huge growth in all the measurement channels. You know, people are going on the mobile. You know, you got to capture their measurements, and you know, people are on Facebook and you know, Twitter, and you name it. They're shopping online. So it's a huge challenge for Nielsen to keep up with this explosion and growth in not only data, but all these new channels, all the exponential growth in data to measure them and provide meaningful insight to the companies. So that's a challenge that keeps us paid and keeps us in our jobs. So answers on demand platform. This is where me and Govind work. We are on the buy side of technology. We measure what people buy. It's a very powerful big data reporting platform. And the uniqueness and power of answers on demand is that we're able to aggregate very large data sets on the fly. So the kind of data that we're dealing with in answers of demand is point of sales data, loyalty card data when you go and swipe you know, your loyalty cards in your stores, panel data. We have panels across the country who feed in their receipts into our platform. The power of we are able to scale, do aggregations on the fly because we use Netezza, which is an MPP, but we're not going to concentrate a lot of into that part of the platform. What I'm going to concentrate on is your right-hand side corner, which is our front-end reporting platform, and that's where we use leverage Couchbase. Our front-end platform is written on top of exe.js, and all our metadata is stored inside Couchbase. And our global search capabilities are powered by Elasticsearch. So rest of the presentation is going to be mainly on that side and concentrating on the front-end tier and our NoSQL databases on the front-end tier. And if there's any questions in the middle, just feel free to stop. And
Are you going to talk about how the data gets into Couchbase?
Yes. So it's basically, I'll answer that right now. It's all user-generated data. It's basically reporting. It's all the reporting templates and report selections are all the metadata that's stored in Couchbase. So the kind of data that we're dealing with, if you see here, the backend volumes are really humongous. We're dealing with the petabytes worth of data. Type of scale that we're dealing with in reporting in the front end is, you know, we have a pretty large user community here, and the you know, the reports are in hundreds of thousands of reports that are run on a monthly basis. I think we have about 6 million report templates in one data center, and the other one has about 10 million report templates. The next 3 slides just shows a sampling of our user interface. And what I want to show here is just not a pretty UI, but all the rich features that we're able to put in the UI layer, leveraging Couchbase. So that's what I want to show here, basically. This is what a reporting builder app looks like. This is where user goes and builds their reports. It's a WYSIWYG kind of application. You know, you go drag and drop what you want, charts and grids and things like that. What I want to say here is we're able to get a very responsive user experience here because the front end's written on ext.js and JSON is the first class object. Couchbase stores first class JSON as their first class object. So there's almost no transformation between the database and the front end. So it's pretty much the definition is stored as is in Couchbase, and we're able to feed that into a UI layer, and we're able to render that. If you look at your traditional other UI layers, there's a lot of transformation between your database layer and your front-end layer, which causes lags and things like that. Highly efficient metadata change management. What do I mean by that? So like I was mentioning before, there's millions of these report templates, and embedded within these report templates are data points. Like for example, I don't know if you can see, but there's like Duracell. So occasionally, Duracell, they would want to change that to Duracell batteries. And we're able to efficiently go and find those instances of that and change that. The way we do that is we leverage views in Couchbase by incrementally building these indexes on the fly whenever the user creates and modifies reports. Flexible data model, we're able to add new features because JSON model itself is flexible. We can add new features on the fly. Different types of JSON objects can reside within the same bucket, not breaking the schemas and things like that. So that was a huge win for us. This is a report player. This is how a report gets rendered. So one thing I want to highlight here is very fast caching layer. So Couchbase gives a very fast caching layer. The gets and puts are really, really fast. That makes our UI also very responsive. We do a lot of offline, out of the JVM processing in Couchbase because it's extremely fast. We cannot hold large amount of memory in the JVM, so we kind of push that into Couchbase. And that makes our processing really, really effective and really, really fast. Can scale without compromising speed. We can do horizontal scaling, sharding. That's a huge plus for us. No single point of failure. There's no master-slave concept in Couchbase. We have nodes that go down all the time, but it doesn't bring down our application. I want to point out here, it is a mission-critical application, and every report run goes through Couchbase. And for the last 3 years that we have been running, we've never had a downtime with Couchbase. We have had nodes go up and down, but in general, the cluster is always up. So data selector app, this is where users go in and select data. What I want to point out here is the deep analytics that we are able to derive leveraging Couchbase by basically writing views on top of Couchbase. So, for example, I was talking about Duracell. We can actually report how many times a user selected Duracell in their reports, and come up with metrics saying, this is probably the top batteries that people are looking at throughout the country. And interactive analytics is the nickel part. Currently we're facing with, usually the kind of data that the deep analytics gives is for business. And they usually come to us saying, give us a report on, what are the top batteries that are being used. We don't want, as architects and developers, we don't want to be in the business of, giving those reports to business. And we want to give the power of that to the business analysts. And that's where Nickel comes in. I think there's tremendous power in analysts and the business who have a little technical expertise to be able to write that queries and derive that metrics themselves. And that kind of frees up our time to do better stuff. Just a very high-level architecture diagram of our front end, largely written on Java. We leverage a lot of Tomcat stuff.
Custom BI.
Yeah, it's a totally custom BI. Now the MicroStrategies or the Tableaus could scale to our needs. So we went ahead and wrote our own custom BI. We use TIBCO, I don't know why. In the data tier, we use a mix of NoSQL and relational databases. What I want to point out here, and probably in the next slide as well, is that we do have a mix for both relational and NoSQL databases. It's not like NoSQL solves all our problems. We've seen that the right mix of these two kinds of fits within our needs. So we use Couchbase for our document store, our caching layer, our views. All our views are written on Couchbase. And we use Elasticsearch for our global search capabilities. But we were not always this cool. I mean, when we started 3 years back, we had humongous challenges, and the next few slides shows why. And the baby picture always cracks me up. But about 3 years back, when we were re-architecting our platform, and then we were looking at our challenges, before we selected NoSQL, we wanted to list out and see, what is that's going to help us cross this hurdle. And then, these were some of the big ones, like the growth. We were stuck in a vertical scaling paradigm. We were using Oracle. We were in our UI layer back then was written on Flex and leveraging XMLs. We were storing XMLs in clubs. So we were seeing tremendous growth in our user base. And Oracle doesn't scale well after a certain point when we just start adding clubs to it. So we were beginning to see cracks in that area. Relational fatigue. If you guys have dealt with release migrations using RDBMS, you know what I mean. It's basically a nightmare. If you add columns with new columns with new releases, it's all the migration that you have to do. That was a huge pain point for us. Since our legacy application was written over time, it had fragmented caching. So each of the components in the front end had its own caching mechanism. Some had EH caching, some used memcache, some used just file-based caching. It was just all over the place. And no ad hoc analytics. Since we were storing things in club, there's no way to introspect within those clubs. If we had to run reports against our metadata, it basically took us a couple of days for a programmer to write Java, pull clubs out, see what to do. Not fun at all. And absolutely no ad hoc querying capabilities. So why NoSQL? Basically, all the issues that we had, things like relational fatigue, are solved with schema-less kind of document model. So we can put in new releases into our model without having to go through this upgrade process. We're able to scale also very well because of the horizontal scaling paradigm. We're able to add new nodes on the fly as and when our data grows. We've seen that with Couchbase, we're able to keep the same performance even with data growth. And just by adding nodes, we're still getting the same performance numbers that we're seeing with a smaller set of nodes. And deep analytics, I think Govind's going to cover this in detail, that how we're able to derive deep analytics leveraging Couchbase, basically with writing incremental map reduce as well as nickel. Right? And cost, you can run this on commodity hardware. It's a huge selling point if you have to sell this to management. Say it's XY, half the cost, they pretty much buy into the concept of moving to NoSQL. I think, Govind, you're going to walk us over the next steps. Yeah.
Okay. Thanks, Arvind. So Arvind set the stage for why NoSQL. So I'm going to walk you guys through why Couchbase and what our journey has been with Couchbase so far. So we started off in 2012. We started kind of slow. We started off with 2.0. We were doing the prototyping and the mobilization phase where we experimented with Couch 2.0, and we liked it right away. So we released it in 2013 for a smaller, Nielsen is a market research firm. So for our syndicated data clients, there are like, which is not a humongous volume, but we started off with the syndicated clients, and we were very successful. So in 2013, we went off with 4-node cluster in one data center, and the environment was very, very stable. So towards end of 2014, like we migrated all our clients over to multiple data centers, about 16 nodes in 2 different data centers that leveraged advanced views and unified analytics along with Elasticsearch. So as I go through the slides, there are more details about what each of the use cases that we went with. Our plan in 2015, towards the end of this year, early next year, is to go live with 4.0, migrate our current instances over to 4.0, and use NQL for interactive analytics and ad hoc querying capability. So I'll walk you through some of our use cases, like fairly quick, and then we'll get to a demo where you can see what our current data model is and how we leverage Couchbase and how NQL would make absolute sense for a business use case like ours. The very first use case is how we use it, like as persistent store, basically for storing JSON documents as well as cache. This is Arvind already walked through that the application is basically a responsive UI, so you need very, very high throughput for the gets and the puts that we deal with Couch. The second use case is the reverse index store. This is one of our, this is our return on investment on what we put into Couch. As I walk through the use case, you'll be able to see how big of a win this is for us. The third use case is unified analytics. Now we have laid the platform, we laid the foundation for storing the data. The unified analytics is basically taking the power of Couch and Elastic and merging the data together to see a holistic view of our platform. And the final use case is the instant analytics or interactive analytics that like a SQL-like interface provides us. So the very first usage model is a document store. I don't know how well you can see from all the way back. What you see here is basically a data selector application where our clients, ours is Answers on Demand, is a multi-tenant software as a service platform where our clients would go into the system and build reports. They make selections across multiple dimensions, markets, periods, products, and facts, and these selections are persisted in Couch buckets as report metadata. What you see in the right extreme is in the UI is basically persisted as a JSON document in Couch bucket, and this is used as a document store. And what you see here in the left nav is basically is a cache. It's a JSON. It's also a JSON document that we don't have to fetch multiple times for every user. On the right side, this is more user specific, but the left navigation can be similar for multiple users of the same persona or a role type. So we cache that part in our Couch bucket.
Do you have different metadata for different user roles?
No, we don't. So what you're seeing here is just a data selector application where users would go in and make selection. So user is another attribute in that document. That's all.
But we have different models for different types of applications.
Right.
So in our front end, it's just not one app. It's like there's multiple applications, and there's just different JSON models for each of those different types of applications.
So how do you define, or how do you manage the metadata?
So in a bucket, there can be multiple different types of documents residing at the same time. But logically, we have split it out into buckets. Like for example, if this is a data selector, we have a bucket called data selector, and all the metadata with respect to that goes into that bucket. But we can have multiple versions of the model within the same bucket.
And the same bucket can also store multiple document types and the model types. In our case, we know this is going to be like every report run is going to have an instance of this document. So we kept this like a separate bucket. The next slide is layout definition document. So this model, this is again a JSON document, but this basically is an instance of what the user drags and drops on the visualizations that they drop. So this is a JSON document in itself, and this goes to a separate bucket. The second use case that even Arvind touched upon was metadata change management. So Nielsen is a data company, so our data gets refreshed periodically. So it, depending on the type of client, it could be like a weekly data refresh or sometimes even sooner than that. So one of the key use cases that we wanted to, we used Couchbase is basically changing the metadata of user reports. Prior to a NoSQL solution, we had this, we had all these documents stored as clubs in a relational database, and we were able to get input fairly quickly, but we couldn't introspect any of these documents. We didn't know how many of those documents had Coke or Pepsi metadata footprint within it. So when there is a change, let's say in this use case, if there is a change for, let's say, vodka on the right extreme selection, change to, let's say, Russian vodka. So in a change like that, we couldn't do it with the relational database sort of scenario. When we are in Couchbase, what we do, we basically run the couch views to identify and emit up front. So we statically identified these are the attributes or the sections of the document that could potentially be changed during a data refresh process. And when the document gets updated to the couch bucket, every time you add that to the couch bucket, there's this incremental index get created, which is basically used for reverse lookup. So when there is a data refresh in the back end, we get the delta changes, let's say vodka changed to Russian vodka sort of a use case. We are able to go do a RESTfully search on for this particular client or across multiple clients. Here is a change that vodka changed to Russian vodka. We are able to pull those search effectively and then pull those documents, make the modification, and put it back into the couch bucket. So in the earlier presentation, there was a question about, why can't you store this in just a binary document in relational database and be done with it, right? There was someone asked. So our use case was we did that with the clubs prior to a NoSQL solution, but which is good if you're just doing the gets and the puts. But if you want insights into your JSON document, you need a NoSQL store, and especially in this case, like Couch came in very, very handy for us.
Are you able to also reverse the change?
Yes. So we have scenarios. Let's say the delta change that we got, like vodka changed Russian vodka, and that's like an incorrect change. Let's say it has to be vodka to new vodka. Couch maintains the versions of the document, so based on the delta, we can reverse it as well.
But what I want to point out here is, we have an extremely complex model, and the Couch MapReduce engine is able to do incrementally index that very, very efficiently. Just to give you some perspective on scale, like if we had to search for alcohol in all our 6 million document set, that's less than a couple of seconds. It's less than 2 seconds, or probably even less.
Yeah.
So it's extremely efficient to find that needle in a haystack kind of scenarios where you have to find a particular change and apply it globally. Is where, if like Govind said, return on investment, that's actually, a perfect scenario for us. It was a good return on investment for us.
I have some view code there that I think I have one of the slides to show that a little further. This is a very similar use case. This time it is on a report definition as against a data selection. It's a different JSON model. So a quick view of the code, what it does is just a smaller snapshot of what the view does is basically, as I show the demo, I'll show you how nested our document structure is. And it was very, very critical for us to have an engine that basically parses recursively and be able to identify and emit those attributes that we would come back and do a data refresh on.
So just a piece of advice in terms of our learnings. If you want to do something similar like this, invest in a very good, powerful I/O. So we had spent a lot of time because if there's not a fast I/O throughput, the views can perform pretty bad. So if
Yeah, we started cheap with a NAS device, and we paid for it a little bit. The third use case is now we have the document sitting in couch buckets. Now we know that we have indices that we can do faster lookup and make changes to it, and two of our business use cases are handled. And the third one is unified analytics. We all run into this scenario where our systems have data across multiple storage units. So we have reporting metadata sit in Couchbase. We have the report audit data that sits in a relational database, and our log data sit in file system. So what we are able to do is able to write a custom connector that basically merges data across all the three different types of storage systems, and able to push that into Elastic. Elastic, we have the footprint of Elastic in our environment to do the global search, and we're able to run dashboarding features on top of it. We use Kibana for that.
Just out of curiosity, anyone's using Couchbase with Elasticsearch here? You guys use Kibana?
Yeah, we actually turned off the replication because of the index updates making it kind of a mess. We didn't get the time series benefit.
Using XDCR?
Yeah.
Okay.
So this is we defined a model. Basically, the one on the top you get the couch index information, and one at the bottom you get the relational database data out of it, and here this application log. And we had to write the custom connector, which sort of builds a unified model to give one view of the attributes collected from multiple systems, and that it gets fed into Kibana. And just a quick dashboard feature set that Kibana offers, that we are able to go in and find what are my top 10 products, what are my top 10 facts, etc. So now you have to combine multiple systems, and then everything is good and golden so far. So the key challenge that we wanted to solve for was we had to statically identify what we are going to look for and write a view code. So our indices had to be created upfront. We know this section of the document had to be emitted first so that you can query against it. That's the feature we had. So Nickel changed it drastically. So Nickel gave us an opportunity to go in and ad hoc go in and query the buckets. So earlier with the view code, you had to write a view code, a JavaScript code. You had to first deploy it, put it in the production, and then go back and write a Java utility to fetch it. All that is handled as part of Nickel. I want to switch to So early this year, we partnered with Couchbase for a beta testing initiative where we started off exploring how Nickel can be an excellent candidate for us to do interactive analytics. So we basically took our test bed, test data, took some of our buckets and moved it into an EC2 instance, a Couch cluster with a beta version of then it was a much earlier version now, it's all upgraded to 4.0 4051. So we moved our data in and identified some of our key queries that would give us like instant benefit, and we played around with this. And when we went back and demoed this to our leadership, they were pretty happy, and they were like, let's go ahead and do the upgrade to 4.0 is what the immediate response was. What I wanted to show before we go any further is the document model that we have, and point out how what the nesting, what is it that's complex about it. So like I said, these are report selections that go across multiple dimensions, and then as you see when you scroll down further, like the hierarchy that our client defines in our AOD platform, need not be a static set. The hierarchy levels could be just 3 levels, or it could be n levels. It could be 20, 30 levels also. So that hierarchical setup could result in the number of child nodes can go as deep as 30, or even just 30. I just picked an arbitrary number. It could be any deep. So this kind of model, this kind of the deep nesting model had to be recursively parsed on the fly. So that's why we wanted to take this, and when we did some of the queries, I walked through one of the SQL example. I'll walk through the unnest example that'll show us like how quickly the unnest feature in Nickel helps us do that. But the top 10 that we had to go earlier, we went through the Elastic and Kibana examples to do the top 10. It comes in very handy with N1QL.
We did get some Couchbase engineers their head spinning, but they looked at this model as like, oh my god. I don't know if it went back to you, Keshav, but they were like, some of the unnesting stuff was pretty interesting to work through.
A quick walkthrough of these, and you might have seen this in the other presentations as well. This is a couch cluster where it's a 3-node cluster, and right now it is a mixture of data index and query nodes. And one thing that we want to take advantage is, as we move to 4.0, is the multidimensional scaling, where we could add more power just to our index nodes, or we could add, if our data growth is pretty fast, we could add another node and call it just a data node, and we'll be able to scale in each of the 3 dimensions.
Is this your test system or live?
This is our test system. It's an EC2 instance that Couch provided, where we moved our data.
It's hosted by Couchbase.
Okay.
Yeah. Can you run some Nickel?
Sure.
Any questions so far? Or Govind's trying to power up his Nickel?
So if your reports have some aggregations or any other roll-ups, where do you?
So that's all handled in the backend tier. All the aggregation is on the fly aggregation is handled at the backend tier. But we do some aggregations from the reporting metadata that we store. Like I mentioned, what are the top products, what are the top markets. We take that data and aggregate using views and Elastic. We're able to do that.
How do you store your reports?
The reports definition are stored in Couchbase, which is
just another.
Yeah, it's the report definitions are JSON objects,
Okay.
and they're stored inside of Couchbase. That's our primary use mode.
Is there any standard around that?
No, that's our proprietary standard.
So what I'm doing here is basically I'm logging into an EC2 instance where I can run my Nickel queries. Nickel is nothing but it's like a REST client that interacts with the Couchbase bucket. So I want to show a sample of simple SQL queries written on top of that goes against these buckets, and show walk through it a little bit. So what I have here is just I can write a simple SQL query. I don't know how much you can see. Sorry about that. What I have here is
Command plus.
yeah, I made it, and
There, yeah.
this looks huge online though.
No, go. Yeah.
So what I have here is a simple SQL that goes against one of our SQL buckets, where I'm fetching what those how many documents that were created by Govind here. So this is like if I were to do the same in the previous versions of Couch, I had to go in and write a view that basically emits these two attributes, the ID and the user ID. Now I don't have to worry about that. So it used to be more, views were more developer-friendly sort of construct, but this becomes very handy when this kind of tool power is given to our product leadership team or our analyst. They're able to go in and run a quick SQL that they want to do. So a good use case would be, let's say we release a new visualization into any of our reports. Let's say we released a heat map visualization that's been a new feature release from our side. So and like after the release, a leadership team could go in or analysts could go in and run a query like, give me all the documents that have type of heat map. So that would give them like initially how much of a client adoption is available. Is how much of clients, how much they adopted to the newer visualization. So this sort of brings you a lot of insight into that data that was not available earlier.
I think we're close to time.
Oh, really?
Can you just run an unnest because we've spent, I think, like probably a couple of months working on that part. Right?
So what I wanted to show was an unnest feature which comes in very, very handy for us. So because we have a very nested structure across the multiple dimensions that we have, we wanted to be able to find, like as we scroll down, okay, you have a selection document. You want to traverse through the document and identify what are the various dimensions that are available. Now you narrowed down and you went to a fact dimension, and you wanted to see within facts what are the most used facts. So what this unnest array basically does is it recursively parses through and surfaces every nested level to a higher level. So that gives us like more a flattened view of the recursive document. So here what we have is a query that says here are your facts, like top 10 facts, with dollar being the most used, and AQ fact and RTL AGP fact. There are several kinds of facts, and this becomes very, very handy for us.
I think we close time with this summary.
Oh, okay. So I'll pass it on to Arvind to do a quick summary of.
Yeah. So when we were moving to NoSQL and Couchbase, we were actually basically looking for a storage and a caching solution, but we got more out of it. Actually, our biggest bang for our bucks is our metadata change management and our search and analytics. So looking into the future, we're actually going to invest more time in some of these things. So the added benefits are more than what we asked for. I'll wait for him to just take a quick picture. So where are we heading towards? I think earlier towards the next part, early part of the year, we're planning to move to Couchbase 4.0 and Elastic 1.6. We're really looking forward to the multi-dimension scaling and the nickel part of Couchbase. I think it's going to be a tremendous win for Nielsen to move towards Couchbase 4.0. Currently, our mobile offering is we're mobile friendly. We want to move towards where we're totally mobile, and there's a lot of emphasis on offline mobile content viewing, and we want to get there. So some of our focus and our energies is going to be spent on that. We want to be able to push our reports from our desktops to our mobile devices and have the ability to have it viewed offline. We want to, our partnership with Couchbase has been really, really good. I think this year has been the best year. We want to strengthen that partnership. It's been mutually beneficial. We have had our own selfish reasons for going into this. Like Govind was saying, the unpack feature, it's huge for us. And there'll be future use cases that we want to suggest to Couchbase and get those features implemented into their servers. So we're really looking forward to that. We continuously engage externally. We're in the Chicago area. If you guys are there, we're in Java meetups. We present at the Chicago Coder Conference. We're very passionate about NoSQL, so you'll probably hear us talk about Couchbase or Elastic or Cassandra or something like that. So we're continuously engaged in that. That's all I had. If people have any questions further.
Does
Nickel support user-defined function? Like, suppose I want to implement rank function in
I think it does. Does it have?
Nickel itself
It-
does not
Right.
write your own custom functions in views.
In views, but does Nickel
Out of the
support?
box.
Nickel doesn't exploit the functions written
yeah,
for views.
yeah,
yet.
Yeah, okay.
Yeah. So, thank you very much, everyone.
Thanks, guys.